So we're going to set up for the heat capacity of a metal lab. So I'm going to go ahead and put it in my table of contents. So this is our fourth lab. And it's actually heat capacity of copper. And I know mine is going to start on page 10. Okay, so we're going to start by putting the title at the top. So this is the heat capacity of copper. And then you're going to put the date, so whatever today's date is. And then next comes your purpose. And the purpose of this lab is to determine or find the heat capacity for copper to be able to compare it to the heat capacity of water. So the purpose is to find the heat capacity of copper to compare to the heat capacity of water. Now, we know that the heat capacity for water is 4.184 joules per gram times degrees Celsius. So that's the number that we're going to be comparing to. So for our hypothesis, instead of just guessing or predicting a random number for the heat capacity of water, or for the heat capacity of copper, we're just going to hypothesize, do we think the heat capacity for copper is going to be greater than, less than, or equal to the heat capacity for water, or 4.184? So we're going to say the heat capacity of copper will be, and we're going to say greater than, less than, or equal to the heat capacity of water, which is 4.184 joules per gram degrees Celsius. Okay, so that was easy enough. After our hypothesis, we're going to put in our procedure. Our procedure for this lab comes in two parts, so make sure you have all the way from step 1 to step 18. So we're going to put each piece in. Okay, so now that I have my procedure thoroughly secured into my lab notebook, either with tape or glue, I used glue, we're going to put in our section for our observations. So right underneath our procedure is a good spot to put observations. Remember, observations are words, not numbers, so this is not going to be our data table. Our data table is going to come next. I'm going to go ahead and show you how to set up our data table for this. Now, we're not going to have a graph. We're just going to have data table and calculations for this one. Actually, I lied. We're going to have data table, we're going to have graphs, and we're going to have calculations. I forgot about the graphs for this one, but we're going to set up our data table first. So if we go back and look through our procedure tells us when we're going to record things. So we need a mass of our metal, so the mass of our copper. And then next, it says we need the mass of the empty coffee cup. And then we're going to add some water to the cup, and then we're going to measure the mass of the cup with the water, and then we're going to be able to calculate the mass of the water. So you're going to subtract out the mass of the cup. So we're going to say mass, cup plus water, and then we'll need the mass of just the water. And then we're going to measure temperature. So we're going to have the initial temperature of the water. So we're going to say Ti water. And then we're also going to measure the initial temperature of the metal, which is going to be the temperature of the hot water bath. So we're going to have Ti of the copper, since that's the metal we're using. And then we're going to record one final temperature at the end. So we're going to have T final water, which is actually going to be the same as our T final for copper. So these last two numbers are going to be the same, but we're going to go ahead and write them separately just so that we can keep it straight when we go to do our calculations. Okay, so I'm going to use a ruler to draw some straight-ish lines. Okay, now after my data table, I'm going to have a spot to sketch in my graph. And so your graph, again, we're going to collect from the LabQuest. So it's going to collect our data for us. And so we're going to have time on the X, and we're going to look at temperature on the Y. So your LabQuest is going to collect this for you. And so just once you're done collecting your data, you'll be able to sketch that in. Okay, and then after our graphs are going to come our calculations. And so there are three main calculations that you need to do, and they're outlined for you at the end of your procedure. So you're going to calculate the amount of energy that the water gained, and then you're going to use that value, that Q, to then calculate the C, or the heat capacity of your copper or your metal. So you're going to use Q equals MC delta T twice. The third calculation that you're going to do is percent error. So I give you the accepted value for the heat capacity of copper, and you are going to calculate percent error using that equation to see just how close your value actually came. And then finally, the last thing that we're going to put in is our summary. And so you have all of the information now to go ahead and do the heat capacity of copper lab.